50,000 companies, 2 million users, I think. 50,000 companies engage Hugging Face. There's some 275,000 models, 50,000 data sets. Just about everybody who creates an AI model and wants to share with the community puts it up in Hugging Face. So today we're announcing that Hugging Face is going to build a new service to enable their community to train directly on NVIDIA DGX Cloud. NVIDIA DGX Cloud is the best way to train models. And its footprint is being set up, our DGX Cloud footprints are being set up in Azure, OCI, Oracle Cloud, and GCP. So the footprint is going to be largely everywhere. And you'll be able to find from the Hugging Face portal, choose your model that you would like to train, or you would like to train a brand new model, and connect yourself to DGX Cloud for training. So this is going to be a brand new service to connect the world's largest AI community with the world's best AI training infrastructure. So that's number one. Where do you find the models? But you want to do this in the cloud, but you might also want to do this everywhere else. And how do you build that infrastructure for yourself? And so the second thing we're announcing today is the NVIDIA AI Workbench. This workbench is a collection of tools that make it possible for you to automatically assemble the dependent runtimes and libraries. The libraries to help you fine-tune and guardrail, to optimize your large language model, as well as assembling all of the acceleration libraries, which are so complicated, so that you could run it very easily on your target device. You could target a PC, you could target a workstation, you could target your own data center, or with one click, you can migrate the entire project into any one of these different areas. Let's take a look at NVIDIA AI Workbench in action.
Generative AI is incredibly powerful, but getting accurate results customized with your secured, proprietary data is challenging. NVIDIA AI Workbench streamlines selecting foundation models, building your project environment, and fine-tuning these models with domain-specific data. Here, AI Workbench is installed on a GeForce RTX 4090 laptop, where we've been experimenting with an SDXL project. As our project gets more complex, we need much more memory and compute power, so we use AI Workbench to easily scale to a workstation powered by 4 NVIDIA RTX 6000 Ada generation GPUs. AI Workbench automatically creates your project's environment, building your container with all dependencies including Jupyter. Now, in the Jupyter Notebook, we prompt our model to generate a picture of Toy Jensen in space. But because our model has never seen Toy Jensen, it creates an irrelevant result. To fix this, we fine-tune the model with 8 images of Toy Jensen, then prompt again. The result is much more accurate. Then, with AI Workbench, we deploy the new model in our enterprise application. This same simple process can be applied when customizing LLMs such as Llama 2 70B. To accommodate this much larger model, we use AI Workbench to scale to the data center, accessing a server with 8 NVIDIA L40S GPUs. We tune with 10,000 USD code snippets and nearly 30,000 USD functions built by NVIDIA, which teaches the model to understand 3D USD-based scenes. We call our new model ChatUSD. ChatUSD is a USD developer's co-pilot, helping answer questions and generate USD Python code. With NVIDIA AI Workbench, you can easily scale your generative AI projects from laptop to workstation to data center or cloud with a few clicks.
Everybody can do this. Just have to come to our website, download NVIDIA AI Workbench. Anybody could do this. Now, it turned out my parents gave me a Swedish name, as you know. It's Jensen. And I'm pretty sure that when they looked up Toy Jensen, that's why it turned out that way. And it took a few more examples to turn them into toy Jensen. Okay, so everybody can do this. Come to the website, early access, download AI Workbench. For the creator of the project, it helps you set up the libraries and the runtimes that you need. You can fine-tune the model. If you want to migrate this project so that all of your colleagues could use it and fine-tune other models, you could just tell it where you want to migrate it to, and one click, it'll migrate the entire dependency of the project, all the runtimes, all the libraries, all the complexities, and it runs on workstations, it runs in the data center, it runs in the cloud. One single body of code, one single project allows you to run literally everywhere. And so everybody can be a generative AI practitioner. Well, what makes it possible to do all this is this other piece of code called NVIDIA AI Enterprise. This is essentially the operating system of modern data science and modern AI. It starts with data processing, data curation, and just, data processing represents some 40, 50, 60% of the amount of computation that is really done before you do the training of the model. So data processing, then training, then inference and deployment, all of those libraries, there are 4,500 different packages that are inside the NVIDIA AI Enterprise with 10,000 dependencies. This represents literally the NVIDIA 30-year body of work, starting with CUDA, all the CUDA acceleration libraries, and everything else is accelerated for the GPUs that are, this couple of 100 million GPUs that are all over the world, all CUDA compatible, make all of them run. It has the ability to support multi-GPU in a multi-node environment, and every single version of our GPU, 100% compatible with everything. And this operating system of AI, if you will, has been integrated into the cloud, integrated with leading operating systems like Linux and Windows WSL2, Windows subsystem for Linux. The second version, WSL2, has been optimized for CUDA and supports VMware. The body of work that we've done with VMware is incredible. This took several years to do, a couple, 2.5 years, for us to make VMware be CUDA compatible, CUDA aware, multi-GPU aware, and still have all the benefits of an enterprise, one pane of glass, resilient, virtualized data center. And so this entire stack of NVIDIA AI Enterprise, this is really the giant body of work that makes all of this possible. As a result, literally everything that you would like to run will be supported by the ecosystem we're talking about here. It's also integrated above the stack into MLOps applications to help you with the management and the coordination of doing data processing, data-driven software in your company, as well as will be integrated into AI models that will be provided by ServiceNow and Snowflake. Okay, so NVIDIA AI Enterprise is what makes NVIDIA AI Workbench even possible in the first place. Now we have these incredible models that are in Hugging Face, that are pre-trained and open-sourced. We can now train them and fine-tune them on AI Workbench. You could run it anywhere because of AI Enterprise. Now we just need some powerful machines. We have powerful machines in the cloud, of course. DGX Cloud has many footprints around the world. But wouldn't it be great if you had a powerful machine under your desk? And so today we're announcing our latest generation Ada GPU, Ada Lovelace GPU, the most powerful GPU we've ever put in the workstation, is now, oh gosh darn it, I just put my fingerprints on there. Can you guys see that? That's not me. Could you? Hey, can I have this cleaned in the future? My bad. Yuck. Let me show you. That's the worst product launch ever, you guys. The CEO pulls it out and goes, yuck. This is the data center version of Ada Lovelace. Sorry, everybody. My bad. They worked so hard. They worked so hard. It was perfect. It's like beautifully lacquered. I'm sad. I'm super sad. I'm super sad. Okay, anyways. Thank you. Thank you. And that's why you should rehearse. All right, it goes into these amazing workstations, and these amazing workstations packs up to 4 of these GPUs. It packs up to 4 NVIDIA RTX 6000s, the most powerful GPUs ever created, and it run real-time ray tracing for Omniverse, as well as train, fine-tune, and inference large language models for generative AI. And it's available from Box and Dell and HPI and Lambda and Lenovo, and it's available now. Okay, so we're in production with these workstations, and with, as I mentioned, Hugging Face to AI Workbench, NVIDIA AI Enterprise, running on Windows 11 with WSL2, you have an amazing AI machine. You could fine-tune GPT-3, 40 billion parameter GPT-3 in about 15 hours on nearly 1 billion tokens. And so you could take your proprietary data, your curated data, you could maybe bring all of your PDFs, and you could fine-tune this model before you ask it, prompt it and ask it questions. SDXL could be trained, and after it could be fine-tuned, as I mentioned, we showed you an example of us fine-tuning it with Toy Jensen. You can now generate 40 images per minute. Okay, 40 images per minute. This workstation will pay for itself, in who knows, depending on how much you use generative AI these days, it could pay for itself in months. Like I said, the more you buy, the more you save. Okay? Incredibly fast, incredibly powerful, and it's all yours. It produces answers in seconds, not minutes in some of the services that are out there. Okay, and so another incredible machine are the servers. And these servers, as you know, getting GPUs in the cloud these days is no easy feat. And now you can buy it. Okay, you could have your company buy it for you and put it in the data center. And there's a whole bunch of these servers, a whole bunch of different configurations. I don't know if you guys could see this. This is a server that has up to 8 of the L40S Ada Lovelace GPUs. And of course, these are not going to be used for frontier models. These are not designed to train large frontier models like GPT-4 or GPT-5. These are really used for mainstream models today that you can download from Hugging Face, or NVIDIA could work with your company to create based on our language model called NeMo. We could create models that are mainstream today that you could use in just about all kinds of applications around your company. And you could fine-tune it with these GPUs. The fine-tuning of a GPT-3 model, okay, so this is GPT-3, 40 billion parameters, takes about 7 hours for about 1 billion tokens. And so 15 hours in a workstation with 4 GPUs, of course, takes less with 8 GPUs. And just in fine-tuning, this is 1.5 times faster than our last generation A100. And so L40S is a really terrific GPU for enterprise scale fine-tuning of mainstream large language models. You can also use it for of course, synthesizing and generating images. Okay? So generative AI for everyone. Everybody could do it now. Hugging Face, NVIDIA AI Workbench, NVIDIA AI Enterprise, these amazing new enterprise systems that are in production today. All right, let's change gears and talk about what's going on at SIGGRAPH this year. I'm pretty sure all of you have already heard about OpenUSD. OpenUSD is a very big deal. SIGGRAPH 2023 is all about OpenUSD. OpenUSD is visionary and it's going to be a game changer. OpenUSD is a framework, a universal interchange for creating 3D worlds, for describing, for compositing, for simulating, for collaborating on 3D projects. OpenUSD is going to bring together the world onto one standard 3D interchange. and has the opportunity to do for the world and for computing what HTML did for the 2D web. Finally, an industry standard, powerful and extensible 3D interchange that brings the whole world together. A really big deal. Now let's take a look at why it is such a visionary thing that Pixar did. It was invented, well, I forget exactly when they invented it, but they open sourced it in 2015. And they've been, of course, using this framework for over a decade, building amazing 3D content. Well, the 3D pipeline is incredibly complicated. The 3D workflow is specialized and complicated. You got designers and artists and engineers. They all specialize in some part of the 3D workflow. It could be modeling and texturing, materials, physics simulation, animation, set design, scene composition. There are so many parts and so many different tools. And because the tools are created by different companies and largely incompatible, import and exporting data conversion is just part of the workflow. And because they're incompatible and because there's all this import and exporting, fundamentally, the workflow has to be serialized. It's impossible to parallelize that. And the converting, of course, all of this data is cumbersome and is error-prone. And so this workflow is fundamentally complex. You could argue that it was just designed to be complex. And this is one of the reasons why creating these incredible 3D animation movies are so expensive and take so much time. Well, one of the visions, the first vision, of course, of OpenUSD is to put the data at the center. Could you imagine if every single tool was natively compatible with USD? Then as a result, data gravitates to the center. Everybody can work in parallel. The interchange and conversion goes away. And instead of a serialized model, you have a parallelized spoken hub model. And so this way of doing work, of course, is incredibly appealing, and it's one of the reasons why the vision of OpenUSD has taken off. Well, there's some 50 tools available now. The industry loves the vision. OpenUSD already has a rich ecosystem. Some 50 tools are now compatible with OpenUSD natively. 170 contributors in the USD forum from about 100 companies. So you got a lot of people really interested in this, and the momentum is growing. It's being adopted in film, architecture, engineering, and construction, manufacturing, and so many different fields of robotics. We're engaged with companies in so many different parts of the industry, all excited about USD because everybody's workflow, like creating movies, is complicated. This is no different than a company who's in manufacturing, a company who's trying to build a new building. So many different specialists, so many different contractors, so many different parties coming together to build something complex. For the very first time, we have a interchange, a standard interchange that can bring everybody together. So super, super exciting. Well, 5 years ago, we started working with Pixar, and we adopted USD as the foundation of Omniverse. Our vision was to create these virtual worlds that make it possible for us to bring world design into the applications that I mentioned. Industrial digitalization at the core of many things that we want to do, not just for, of course, creating amazing movies and broadcast and video games, but also to take 3D worlds, physically based, real time, into the world's industries. We felt that we could make a real impact. And so we selected USD. It was a brilliant move. The team made just a visionary move to partner with Pixar to select USD as the foundation of Omniverse. This is probably the world's first major platform, incredible database and engine system that was built completely from the ground up for USD. Every single line of code was designed with USD in mind. The platform for USD for describing, simulating, all the things that we just mentioned. And so Omniverse was designed to connect. It's not a tool in itself, it's a connector of tools. It's not intended to be a final production tool. It's intended to be a connector that make it possible for everybody to collaborate, interchange, share, live work. Okay, so Omniverse is a connector. Well, let's take a look at how the vision of OpenUSD came together. And this is just a fantastic illustration. Starting from the left here, I think this is Adobe Stager, Houdini. This is a modeling system, Maya, or animation system, modeling system. This is Omniverse, Blender, RenderMan, Pixar's RenderMan, and Unreal Engine from Epic, a game engine. Literally all OpenUSD. One data set ingested into everybody's tools, and it looks basically the same. Everybody's rendering system is a little different, and so the quality of the rendering is a little different from tool to tool, but one data set available and usable by every tool. This is the vision of OpenUSD. So incredibly powerful. Well, we've been investing in USD now for over 5 years. This SIGGRAPH is the 5, if you will. We've been working on USD now for about 5 years, the SIGGRAPH. And we've been working on extending USD to real-time and physics-based systems for industrial applications. We brought RTX to it. We extended USD with a schema for physics, real-time physics and offline physics. We added CAD to USD, connect USD to a whole new industry. We made it possible to understand geospatial data, to recognize and understand, comprehend, consider the curvature of the Earth. We integrated it with an AI runtime, as well as a framework to build generative AI. For example, the deep search that we showed you, ChatGPT or ChatUSD that I'll show you in just a second. We extended USD for assets that are physics accurate, physics aware. So we call it sim ready. It's particularly interesting, particularly important for robotics applications, so that the joints move accordingly and such. And we took USD and made it hyperscale so that we can expand it and grow it, make it support data sets of enormous scale, and put it in the cloud, connected it with OpenXR and RealityKit so that we can stream from the cloud to spatial computing devices. Well, for the last 5 years, we've been working on, Omniverse has been building and working, collaborating with the industry on USD. Let's take a look at this. Everything you're about to see is a simulation. Everything is real time. And so take a look at this. This is the latest of Omniverse. Doesn't that just make you happy? No art, all physics. Physics make you happy, doesn't it? Physics makes you happy. Okay, well, we wanted to put Omniverse everywhere. You could download Omniverse from our website and run it on your PC and your workstation. For enthusiasts and designers, that's perfect. You could also license Omniverse for enterprise. And for enterprises that are using it across many different organizations, we even set up a managed service for you inside your company. We're putting Omniverse now in the cloud so that we could host and serve up APIs that can be connected to developers and applications and services so that you can have the benefit of some of these amazing capabilities. And so we're setting up Omniverse Cloud. Now, Omniverse, as I mentioned before, is not a tool. It's a platform for tools. It's not a tool. It's a platform for tools. And we created a whole bunch of interesting tools to help you get started. There are reference applications, and many of them are open sourced. One application, for example, that I really love is Isaac Sim. It's a gym for teaching robots, for robots to learn how to be a robot. And because it's so physically accurate, the sim to real gap is reduced. And so theoretically, you should be able to learn as a robot how to be a robot inside Omniverse. And that neural network, that software, could then be put into a local embedded device like a Jetson or one of NVIDIA's Jetson computers, robotic computers, and the robot can perform its task. Okay, and so we would like to put Omniverse in as many places as possible. There's a whole bunch of different applications. And this SIGGRAPH, we're announcing a few new APIs, really cool APIs. Now, we demonstrated a really cool API just recently. It's called ACE, Avatar Cloud Engine. And so it understands speech, so you could do speech with it. It talks, it recognizes your voice, speaks to you. Based on what it's saying, based on the sound that it's making, it animates the face accordingly, audio to face. And so we call that the ACE engine in the cloud. We're going to show you a couple new APIs. And this one API, this is the RunUSD API. Of course, this should be the first API. What do you guys think? Pretty cute, huh? And so you send to the cloud USD. And what comes out of the cloud, what streams from the cloud onto your device in OpenXR or RealityKit to your spatial computing device will be this incredibly beautifully rendered and, very importantly, interactive USD. So let's take a look at it. So for USD programmers, USD developers, you will have hours of joy, just hours and hours of joy. And you can just create your USD content, USD asset, load it up on NVIDIA's Omniverse Cloud, and enjoy the device, enjoy the asset on your device. Now, this allows you, of course, to test the compatibility of your USD. And so we now have a universal compatibility tester up in the cloud. And so whenever you have USD content, big or small, you could load it up on Omniverse Cloud. And independent of which version of USD that you're using, we'll test it for compatibility. Okay? And so this is going to be free for developers. There's another API that we're creating. And we showed you earlier how we used AI Workbench to train this model, to fine-tune this model. We started with Llama 2, and we fine-tuned it for USD. And so let's take a look at the video.
For USD developers, building, profiling, and optimizing large 3D scenes can be a very complex process. ChatUSD is an LLM that's fine-tuned with USD functions and Python USD code snippets using NVIDIA AI Workbench and the NeMo framework. This generative AI copilot is easily accessed as an Omniverse Cloud API, simplifying your USD development tasks directly in Omniverse. Use ChatUSD for general knowledge, like to understand the geometry properties of your USD schema, or complete previously tedious, repetitive tasks, like generating code to find and replace materials on specific objects, or to instantly expose all variants of a USD print. ChatUSD can also help you build complex scenes, such as scaling a scene and organizing it in a certain way in your USD stage. Build bigger, more complex virtual worlds faster than ever with ChatUSD generative AI for USD workflows.
ChatUSD. ChatUSD. Now everybody can speak USD. And ChatUSD could be a USD teacher, it could be a USD co-pilot, and help you create your virtual world. Okay? Enhance your productivity incredibly. And this is going to be also available on the Omniverse Cloud. Well, I showed you some examples. Probably the largest opportunity for the world of IT, for software, and for artificial intelligence is to help revolutionize the world's heavy industries. There's just enormous amounts of waste, as we all know. $50 trillion worth of industry. Over the next several years before the end of the decade, there will be trillions of dollars of new EV factories, battery factories, and new chip fabs that are going to be built all over the world. Not to mention the enormous number of factories that are already in operation. Some 10 million factories are in operations today. This industry would love to be digital. They would love the benefits of all of our industries. But unfortunately, their industry has to be physically coherent. It's physically based. They build things. They build and operate physical things. But they would love to do it digitally, just like us. And so how can we help them do that? Well, this is where Omniverse and artificial and generative AI comes together for us to be able to help the heavy industries of the world digitalize their workflow. Just as modeling and texturing and lighting and animation and set design and so on and so forth are all done by different groups in a very complicated pipeline, this is very much the case of the world's heavy industries. Every one of their organizations, from design to styling to engineering and simulation and testing to factory building and design, factory planning to build the products, and even operating these software-defined, robotics-assisted products in the future, all of this is done completely mechanically today. That entire flow could be digitalized, and it could be integrated for the very first time using OpenUSD. This is the incredible vision of OpenUSD, why we're so excited about it. If we could only augment it with real-time capability and physics simulation capability and make it so that every single tool is connected to Omniverse, we can digitalize the world's industries. Well, their excitement is enormous because they all would love to have the productivity, would love to reduce the energy consumed, would love to reduce the waste, would love to reduce the mistakes in digital long before they have to build it in physical. And so this is Mercedes. They're using Omniverse to digitalize their manufacturing lines. This is Mercedes using Omniverse to simulate autonomous vehicles. This is BMW using Omniverse to digitalize their global network of factories, some 30 factories. They're now building it in Omniverse without breaking ground and doing the entire integration a year before the factory is actually even built. Using Omniverse to simulate new electric vehicle production lines. Remember, the placement of the factory, the planning of the factory, and the programming of all the robotic systems are just incredibly complicated. In the future, entire factories will be software-defined. The factory will be robotic, orchestrating a whole bunch of robots that are building cars that themselves are robotic. So robots building orchestrating robots, building robots. So that's the future, and everything is all software-driven. Everything is all AI-enabled. This is BMW using AI to drive their operations. This is Wistron using Omniverse to digitalize their production line to build this machine. As I mentioned, 35,000 parts, incredibly complicated. One of the most expensive, one of the most valuable instruments that's made anywhere. And so having that line be completely robotic and automated is really important. This is Pegatron using Omniverse to digitalize PCB manufacturing. Again, this is the PCB of this incredibly complicated PCB motherboard. This is the most complex motherboard the world's ever made. TechMan is using Omniverse to test and simulate cobots. It's not surprising to you, but most cobots, most robots today are not very autonomous, not very AI-driven. Programming the robots usually costs way more than the robots themselves. I heard a statistic that the robot for a manufacturing arm for the automotive industry is something along the lines of $25,000. Not very much, but programming it could cost $250,000, which is very sensible. We would like to have AI be self-programming these autonomous limbs. So TechMan is using Omniverse to test and simulate cobots. They're also using Omniverse to build applications to automate optical inspection. Of course, for PCB lines, the cameras can be stationary. The product, the manufacturing device system is just rolling by you. But for many things like cars and other very complicated systems, the optical inspection has to follow the curvature and, of course, the various contours and shapes of the product. Hexagon is using Omniverse to connect, just as we've connected tools all over the world, Hexagon is using Omniverse to connect their own tools. This is one of the most powerful things that they observed in Omniverse. Whereas they had different groups and different teams that are in silos, and because they're incompatible tools, getting them to connect together was hard. And so this was a company organization and a company management challenge. So very first time, using Omniverse, they broke down the silos, they connected all the different teams, and they became one unified company for the very first time. Really, really cool. This is Ready Robotics using Omniverse to build applications to simplify the robot programming process. In the future, robot programming is probably going to be about explaining in prompts what you would like the robot to do, showing it a few examples, and just as we taught our language model, our generative model Toy Jensen, just as we taught the generative model USD, we're going to teach a generative model of the future, a robotic generative model, a few examples, and it will be able to generalize and do that task. Amazon is using Omniverse to digitalize their warehouse. The warehouse is robotic. Giant system. Help their workers inside not have to walk as far. Amazon is using Omniverse to simulate their fleet of AMRs. These are autonomous moving robots. And using Omniverse to generate synthetic data to train the perception models, the computer vision models of these robots. You could also use Omniverse to create a digital twin. NVIDIA is creating a digital twin of the Earth, the climate system of the Earth. Deutsche Bahn is using Omniverse to create a digital twin of their entire railway network so they could operate it completely in digital. Now, in order for that to happen, Omniverse has to be real time. Well, let me show you one more example. And this one example is about human designers, architects working side by side with generative AI models from different applications and different companies. And together, they will automate and try to and help do industrial digitalization a lot more rapidly. Okay, roll it.
Planning industrial spaces, like factories or warehouses, is a long, complex process. Let's see how you can use NVIDIA Omniverse and generative AI to connect your OpenUSD to fast-track planning concepts, like a storage extension to an existing factory. Use SyncTwin's Omniverse extension to quickly convert a 2D CAD floor plan into a 3D OpenUSD model. and populate it with SIM-ready OpenUSD assets using Omniverse's AI-enabled deep search. Then use prompts to generate physically accurate lighting options with Blender GPT. Realistic floor materials with Adobe Firefly. And an HDRI sky dome with Blockade Labs. To see the new space in context, compose it on a cesium geospatial plane next to your existing factory digital twin. Then, to share with stakeholders, use one click to publish the proposal to Omniverse Cloud GDN, which serves a fully interactive review experience to any device. Fast-track your factory planning process with NVIDIA Omniverse and generative AI.
How incredible is that? Remember, it started with a 2D PowerPoint slide, and it ended with a virtual factory in spatial computing. That is incredible. PowerPoint to a virtual factory. 2D to spatial 3D. So this is the future. This is the future, and this is how everything comes together. USD, of course, is foundational in that journey, and Omniverse foundational in that journey, and generative AI. Well, this is what Omniverse is. We're super excited about the work that we're doing here. We're so happy that we chose OpenUSD as the foundation of Omniverse and all of the work that we've done to extend it into real time, into physics-based applications. The number of partners that we have is just growing incredibly, and it covers so many different industries, as I mentioned, from manufacturing to robotics and others. And we hope, and this is the beginning of a journey, that we will finally be able to digitalize, to bring software-driven, artificial intelligence-powered workflows into the world's heavy industries, the $50 trillion worth of industries that are wasting enormous amounts of energy and money and time all the time because it was simply built on technology that wasn't available at the time. And so Omniverse for industrial digitalization. Well, all of this momentum that we've already seen with OpenUSD is about to get turbocharged. Alliance for OpenUSD was announced with Pixar, Apple, Adobe, Autodesk, NVIDIA as the founding members. The Alliance's mission is to foster development and standardization of OpenUSD and accelerate its adoption. So whatever momentum we've already enjoyed, the vision that we've already enjoyed, it's about to get kicked into turbocharge. Well, I want to thank all of you for coming today. We talked about SIGGRAPH. SIGGRAPH 2023 for us is 4 things. It's about the transition of a new computing model. The very first time in decades that the computing architecture is going to be fundamentally redesigned from the processor to the data center to the middleware, the AI algorithms, and the applications that it enables. The processor we created for this era of accelerated computing and generative AI is Grace Hopper, and we call it GH200. We have NVIDIA AI Workbench to make it possible for all of you to be able to engage generative AI. NVIDIA Omniverse now has a major release with generative AI, and of course, release and support for OpenUSD. And then finally, whether you want to compute in the cloud or do AI in your company underneath your desk or in your data center, we now have incredibly powerful systems to help you all do that. I want to thank all of you for coming, but before you go, I have a treat for you. This is an anniversary, I understand, of computer graphics. SIGGRAPH has been a really special event and a very special place, in computer graphics, as you know, is the driving force of our company and very dear to us. We have dedicated probably more time, more engineering, more R&D, quarter of a century, over a quarter century, well, 30 years, dedicated to advancing computer graphics. I don't know any company who has invested so much. This industry is dear to us. The work that you do is dear to us. And if not for the work that you do, all of you who come to SIGGRAPH each year, how is it possible that AI would have achieved what it is today? How would it be possible that Omniverse would be possible or OpenUSD would be possible? So we made something special for you. Please enjoy.
It all started over 50 years ago with a simple question. What if a computer could make pictures? How could we use them? And what would they look like generations from now?
Hello, folks. I'm Mr. Computer Image.
Welcome in. I hope you're hungry.
Thank you all for coming. Have a great SIGGRAPH 2023. And remember, accelerated computing and generative AI, the more you buy, the more you save.